So now we get into factoring a polynomial. So we know that every polynomial that has a degree that's greater than 0 with real coefficients, not unreal coefficients, can be written as a product of linear and quadratic factors. That means they're either going to be binomials or it could be trinomials. And we know, or well, what we're going to know is a quadratic factor with no real zeros is said to be irreducible, or prime, is what we know it. Or you could also call it irreducible. Let's get this pen working. Irreducible over the reals. So what that really means, if it is prime or irreducible over the reals, if you have an x squared plus 1, a lot of people don't see that as a difference of squares, but it actually is a difference of squares. If you have two terms, one's a square and one's like another perfect square back here, it is a plus and a minus, but notice you have an I. So a way to remember that is if you have an x minus I times an x plus I, then if you distribute x times x, that's a difference of squares, you get x squared minus an I squared. And remember, for I squared, if I squared is equal to a -1, this is really x squared minus -1, which is just x squared plus 1. So it is true, but you're going to have imaginary solutions. That's why it said irreducible over the reals, but it is reducible over the complex numbers. On the other hand, you may have something that is irreducible over the rationals. So that means, sorry about that, anytime you have something that's irreducible over the rationals, well, your rational numbers would be, or irrational numbers would be just radicals. So these are irrational. It means it's irreducible. You don't get any real nice pretty integers here. So if we have x squared minus 2, you guys have already learned that that's an x minus radical 2 times x plus radical 2. So let's move on. So here we have a degree of 4 polynomial, and we need to find all of our zeros given that this is 0. Well, if 1 plus 3i is a 0, we also know that 1 minus 3i is going to be a 0. So if we were to take 1 plus 3i times a 1 minus 3i, just kidding, that's not going to work out so hot. If you have your zeros, let's erase this. If you have your zeros, then the way you write your factors would be 1 minus 1 plus 3i. That's an x, not a 1. HML. And then you have x minus 1 minus 3i. If we FOIL this, x times x is an x squared, x times a -1 is a negative x times a negative 3i is a negative 3xi. So we're done distributing this x. So if we take -1 times all of this, this is going to give us a negative x, a positive 1, and a positive 3i. So we're done with that -1. Now we need to take 3i times everything. So 3i times an x gives us 3xi minus 3i minus 9i squared. So let's clean this up, and when we do, we're going to have some terms that will cancel out. We're going to start with our x squared. So we have an x squared. So we're done with that. Now let's find all of our x's. So we have a negative x here, another negative x, and no other x's. So that's going to be a negative 2x. And then we have negative xi and a positive xi, or positive 3xi. So that's gone. That's gone. So we don't have to worry about that. This positive 3i and this negative 3i are gone. And what we have left are a plus 1 and a minus 9i squared. So remember what we talked about before when we said that I squared is equal to a -1. And what that means is basically you cancel out your I squared and make this a plus 9. So after all of that multiplication, we can finally say, hey, we have an x squared minus 2x plus 10. So that gives us 2 of our zeros right there. Now the reason we had to do that is because if we take this polynomial and divide it by this polynomial, that's going to give us another x squared where we can find the zeros for that problem. So we're going to go with x squared minus a 2x plus 10, and we're going to divide, I don't know if I left enough room. We're going to divide x to the 4th minus 3x cubed plus 6x squared plus 2x minus 60. So when we do that, you get x to the 4th divided by x squared. Well, that's just x squared. That's what goes up here on the top. And we got to take x squared times everything. So that's x to the 4th minus 2x squared plus 10x squared. Remember, if this ever goes too fast, you always have the option of stopping it. So let's change your signs. So this is going to make this a negative x to the 4th plus 2x squared minus 10x squared. And let's add down. So you have negative 1x to the 3rd minus 4x squared. Bring down the 2x. So now I'm going to take my first term here, which is a negative 1x to the 3rd, and divide it by my first term out here. So divide that by x squared. That gives you a negative x. So I'm going to put negative x right here. And then we multiply. So you get negative x to the 3rd plus 2x squared. Man, there's a lot of work in this problem. That's part of the reason I like it. And then we go through and change all your signs. So plus, negative, plus. Those are gone. If those don't cancel, you didn't do something right. So you have negative 6x squared plus 12x minus 60. So then we're going to take our first term underneath here, negative 6x squared. I like writing it over here. Some of you might want to start doing that because some of you are not getting this part correct. So we'll put minus 6 up here. And you multiply all that. So you get negative 6x squared plus 12x minus 60. And you're going to find out that once you change all your signs, everything cancels as it should, which means we have a remainder of 0, which is great because now we can factor this by setting it equal to 0 and find our other two zeros. So if we factor this into x minus 3 times x plus 2, that's going to give us x equals 3 and x equals negative 2. So if we want to list out all of our zeros, you should have 4. You have negative 2, a positive 3, those are your real zeros. You have a 1 plus 3i, and then you have a 1 minus 3i. So that's probably going to be the most difficult problem you do just because there's a lot of work. So make sure you save yourself plenty of space on your paper.